For coming to learn about Bazel plus Python, my name is Alex. I'm an Aspect build and I work on lots of Bazel stuff. I've been contributing to Rules Python some over the years. With me, our teaching assistant today, Reed McKenzie, who also works on Python rules, both the upstream Rules Python and also the Aspect version. And let me get started by opening a browser because I'm slightly unprepared. And I've got a copy of the training material that you all can follow along with as well if you'd like to. So it's at training.aspect.build, which will redirect you to this site. It does ask for a login, but it's doesn't require, you can just log in with your Gmail or whatever you want. Obviously, you can also just follow along on the screen that I'm presenting. So I'm going to talk through some of this material. We're also going to do a hands-on code lab, and I will introduce that in a moment. So yeah, with that to start us off, I think we have 2 hours, which is pretty generous, so I don't have to speak as fast as I sometimes do. Please let me know if I am speaking too quickly. I would also love to take questions at any point. I'll also pause at some moments to solicit questions from you. So with that, we are going to Bazel102 about Python. Okay, so Python kind of grew up at Google. Guido, the benevolent dictator for life, worked there, same time as I did. And we don't need to look at my stuff on my desktop. And so Python and Bazel, you would expect kind of to be natural, siblings, because the ecosystem that Python was developed in, Google 3, the monorepo at Google, tons and tons of people use Python. Unfortunately, what happened is that it's totally weird because they grew up together. They don't look anything like the way that Googlers use Python with Blaze doesn't look anything like the way you would want to use Python in the real world. And since I believe we're here in the real world trying to use Bazel on real projects, I think it's better for us to take the approach of let's make this less Google specific. Okay, so a lot of the course today is going to try to reintroduce you to the idea that Python doesn't have to be weird under Bazel, doesn't have to be unapproachable. If you go to Stack Overflow and you look for how do I do Python, most of those answers should still work. The editor should still work. Like we're going to it's a little bit of a Mythbusters. I heard Bazel was bad with Python. It's not. Okay. We're going to use Bazel 9 because it's out. Yay! Everybody upgraded at work yet? Okay. It's only release candidate 1, but it is pretty exciting since we're all here for BazelCon to have some fresh material to talk about. So that's already included in the code lab we're going to do. We're also, of course, going to use Rules Python. So Rules Python is the rule set that came out of Google, is still maintained by Ricky Levasseur, who's a Googler who, I don't know if any of you remember this headline that Google sort of fired the whole Python team and then sort of rehired it in somewhere else. He, out of, I think, the goodness of his maintainership heart, is still working on this, even though it's not really his day job anymore. So that is awesome. And we will be using parts of Rules Python. In addition, a couple years ago, our company Aspect made our own layer on top called Rules Py. And what Rules Py is trying to do is be more compatible with the Python ecosystem and a little bit less Google weirdness. Reed's going to talk at the end of the session today about changes that just landed or are landing today in Rules Py to take advantage of UV and the lock file there, which makes it even less of removes some more of the rough edges, right? So we can do some demos of some really cool stuff that is about to be ready. There is a Rules UV already. I should mention, for those who don't know, UV comes from Astral SH, which is a company that's been building Python tooling. They started off by building Rough, which is an incredibly fast formatter and linter to replace Black and Pylint. They are rewriting things in Rust. Same thing that's happening in JavaScript land. It turns out scripting languages are really convenient for product engineering, not that great for doing build systems. Basically just too slow, or they need to sort of be stateful and have a daemon running in order to be fast, and that's also not good for us under Bazel, so thank goodness. UV and other tools like that. There's another company, prefix.dev, that made something called Rattler and Pixie. There's, in JavaScript land, there's a bunch of these, so there's a lot of renewed activity in building much faster developer tools in Rust, and we're going to be using those. For the main part of the course today, we're going to use UV only to compile the locked requirements file, but we'll show how we're going to be able to use it for more in the future. There's a video here, which maybe we'll replace with the one from today if I do an okay job. And with that, I will get started on our first section, where we're going to just hello world, right? We're just going to, how quickly can I make a little Python program and see it work with Bazel? How much weird stuff do I have to do? And for this course, we're going to be using this Bazel starters. So let me talk about this for a moment. So I've made this GitHub org with a bunch of starter repos for Bazel. This is not a minimum, like there's only 2 files in here kind of approach. This is a batteries included, what would it look like if Python was really good with Bazel, and everything that you need is already in the repo. That's true for all these other languages as well. So it has things like linting setup, which we're going to do. It has build file generation. It has scaffolding. You can see a bunch of other languages are here. Added Kotlin recently. I don't know if Justin's in the room, but he prodded me into that at DPE Summit. And these are all live updated from another repo, which is the source of truth, which is just this template repo over here. So in case you see any issues and want to make PRs to help out, like you make the PR here. This is where all the languages live, and it basically uses Go templating inside of this project snake directory, so that this is like the kitchen sink of all languages, and then the Python training we're going to use is a subset that's got conditional fencing in some of these files so that gets templated out. Okay. Now, in order to work live, you could use your computer. Number one, I don't know how powerful the conference Wi-Fi is this year, but generally, if all of us are doing a pip install at the same time in this room, we could see what happens. Like, you know, people out having their coffee will be like, I can't get onto Twitter.
Download LLVM.
Right. Yes, you'll download LLVM, which will make everybody sad. Also, your computer is probably like set up for work or like has some weird stuff on it. And the whole thing with Bazel is it's supposed to be reproducible, so we're going to use a reproducible environment. So these template repos you can create in GitHub code spaces. I just learned, so if you were to click this button, it will give you the smallest possible code space. You will get 2 CPUs and, I don't know, a gig of RAM or something, and it takes like 5 minutes to boot up. So there is a trick to get a faster version of this, and if you want to follow along, I encourage you to do so. So you go to github.com/codespaces to make a brand new throwaway environment to play with Bazel, right? Like there's no Bazel playground, there's no web page you go to and you just start typing build files and see what happens, and then you close the tab and it's gone. This is actually very close. So I've already made one which I'll boot up, but if you were doing this, you would do new code space, and then you would choose Bazel starters /pi. The default branch is fine, US East, because that's where we are. Now notice here, there's a dev container configuration. I'll show this briefly just so that you know that there's no sort of tricks going on. There's nothing up my sleeve. This is going to give us just a Bazel binary and a tool called dir-env, which is a convenient utility. We'll talk about how that sets us up. And then importantly, we just grab like a giant honkin' machine because GitHub gives it to us for free, or you know, they gave it to me for free until I started doing this demo too much, and then they have made me pay, but I don't think they'll make you pay. Yes, code space usage is paid. Wait. Is code space usage for everybody in this repo paid for by me? I actually don't know the answer to that. I guess we're about to find out.
Thank you.
Woo!
Put those Azure credits to work.
You know, live demos are only exciting when there's like a hint of possible disaster. Okay, so I've got one apparently called Legendary Guacamole. So when you create one of these, you'll be dropped into this README. I guess it's booting back up again because it's been quiet for a couple hours. Okay, so we're gonna use this Bazel starters thing. And obviously, if you're working in your own repo, you don't have the option of starting greenfield like this, but I think you can still borrow a lot of these patterns. Okay. Speaking of tricks up my sleeve, by the way, there's no Python on that container. Okay, we are not going to have a system interpreter. We are allergic to that. It's probably the wrong version. Probably has some sort of like weird libffi compiled into it. I don't want to know. I don't like you all have computers. They probably have some weird Python on them. Don't want to know what it is. We're not going to use that, right? In fact, we're going to force ourselves to not have any system Python. So this is going to be like the Bazel hermetic way. Okay. So yes, you can wait a few minutes for the scripts to come up. It already has Bazel installed, and there's also going to be a prompt about some recommended VS Code extensions in this repo. So this is using VS Code in the browser, and there's some recommended extensions that show up over here in the nav. I did not choose to install Rough this time. At minimum, to make all the stuff work really well in the code lab. I've got the Bazel extension and the Python extension, just the standard recommended ones, because we want to see things that are working well. Okay. Also, there's a wizard inside of that template repo I showed earlier. So if you don't want to pick like the Python setup, you can actually go through a set of like choose the languages you want. So you could choose like multiple languages, and you could do more going through the template. Okay. So we do have a working development environment at this point, and I'll walk through a little bit more of how that thing is set up. But first, I want to make good on this promise that we can do Hello World really quickly, and it looks like Python's not so hard. So we'll make a folder called app, and we'll just stick a dunder main file in there with some. We're gonna talk to this website. I used to use W3 Schools, but they started returning 403 for my demos, so hopefully this one doesn't. Okay, so I have an app underscore main.dunder main.py. Sorry, I wasn't supposed to have a build file yet. So this is a simple Python program. It does require a third-party dependency, though, right? We're using requests, which does not get shipped with the Python interpreter. And so I've also edited my pyproject.toml file to have requests as dependency. No constraints on the versions, like simple. I added this one line 13. And if you're following along, you would do the same thing. So regular Python world, this should work, right? I've got a dunder main, and I said that I depend on requests, and it should all just work. I shouldn't have to do anything weird. And so the demo here is basically we're going to do Bazel run Gazelle, which is already set up in this repo. This is using the Gazelle extension that comes from the rules Python repo. Although I've pre-compiled it for you, so you're not going to wait for Go code to compile, and you don't need CGO to be functional, and other engineers on your team don't. Like, first-time user experience of waiting for some weird tool to compile is not what we expect to happen, right? Things should be pre-built for the common case. And so what we see is a build file was created for us. And so now, sorry, let me make this bigger. We don't need whatever agent that is, at least not until I run into trouble. So Bazel run app app underscore bin, and talk about that warning in a second. I'm not sure why this is slow. I think it's my first build in this repo. We'll probably expect Bazel to be warming up. Okay. And so we got 0, 0. Wow, what's the chances that I got 0, 0 as my random byte? Let's try again. Okay. C3BA, that sounds more random. Okay, so our app is working, right? We just made a Hello World Python app, and it has a third-party dependency, and I didn't have to do anything weird, and it works. So let's dig into a little more detail on how that happened. So first of all, let's start from the PyProject file. So I had a dependency, and the dependency from here is not what Bazel reads. Okay, so under the covers, something is going to run a tool, and by something I mean a Bazel repository rule, and in this case right now it's pip parse. So pip parse from rules Python wants to read a locked requirements file. It's important for the requirements file to be locked because you might think, oh, if I say requests equals 1, 2, 3, I'm all good, right? Except that it has transitive dependencies, and we want those to be locked as well. Both for supply chain security, there'll be hashes in that file, but also just to make sure if I check out this branch again in 3 months and do this demo again, I want to get the same results and not accidentally have something different, right? And you all have experience going to production and something is not behaving the way it did when you wrote it. So for that to happen, the next file we'll visit is the module.bazel file. So how many of you are already using this file in some way with BZLmod? Little more than half. Okay, that's good. Yeah, Bazel 9 doesn't do the old way anymore, so you are now forced to use module.bazel. And so this has a bunch of rules in it, including rules Python and the rules Python Gazelle plugin. And down here we have our Python setup. So we grab the pip extension, we tell it which Python toolchain we want. This downloads a precompiled one from Astral.sh, the same company that makes UV and Rough. They actually took over a project from Gregory, I don't know how to say his last name, SCO. Indy Greg is his GitHub handle. So he basically figured out how to make mostly statically compiled Python interpreters that you can just download and run. Of course, the quotes there is because the Python interpreter is famously hard to actually statically compile. And there are weird cases where you have a different Xcode version than the person next to you, and you can get a Python interpreter that doesn't work because it assumes it was linking against symbols that were on on the other machine. I would say for 99%, we can just pretend that Python doesn't have that problem. So we're going to have Python 3.12. It came from somewhere. Like I said, it's not on the machine we started from. And then we have the thing pip parse. Okay, so pip parse, its job is to bring the third-party dependencies into Bazel's understanding of the world. This does not point to the pyproject.toml file, right? This points to a file called all.txt under the requirements folder. It's called all.txt because right now in this repo, I have a single transitive closure of dependencies for the whole mono repo. So I've opted into a mono build style closure of all the Python dependencies. That may or may not work in all repos. It's not required to do it that way. It gives better, it removes some rough edges. We'll talk later about what those rough edges are. Okay, and then there's this use repo, which is just Bazel mod syntax that says I'm allowed to mention @pip in my build files, right? Okay, so follow the thread one further to requirements all txt. And this is where the locked requirements appears. And so this is where we see like request shows up here, but so does certify, which is a dependency of requests. And charset normalizer, which for some reason has a bunch of hashes. I guess that's because it's a source distribution. Like
Giant list of pre-built wheels.
okay, giant list of pre-built wheels for like lots of platforms, most of which I don't use. This format is not very good. Okay, so this is when we talk about the UV lock file at the end. Much better. This format doesn't tell us like how do I lay out a site packages folder that contains these things. Like there's a lot of like sort of draw the rest of the owl, so to speak, about this file. But this does give enough information for rules Python to read this file and give us the ability to depend on @pip//certify, for example. I don't know if it's certify. Right, and in our case, we want @pip//requests. Okay, so there's one more bit I didn't show, which is that there's a little script here called repin that I ran, which just does a couple Bazel run commands to basically repin the dependencies. So every time I change the pyproject.toml, or you might have a requirements file to express your dependencies, you may have them sprinkled around the repo, which I'll show in a minute. You do need to like first run the lock file generator, right, so that all.txt is updated. And then the Python Gazelle extension wants to write a manifest file. And so we need to update that as well. And after we've done those steps, then we should be able to generate build files. And I think for the sake of just finishing the story, if we look at this gazelle_python.yaml, this is what that last step does. So the rules Python Gazelle extension basically, like the annotated types package provides an import called annotated types. They both use underscore. Okay, everything in this file looks kind of boring, right? It's just a bunch of mappings of a thing to itself. However, look at line 38. Oh, if you wanted to import YAML, you got to get the package called PyYAML, right? And Python has this horrible problem that there is no way from an import statement to have any idea what package might give you that import statement. Maybe it comes from your monorepo, and like the interpreter has this import logic that is terrible. So this YAML file needs to be here in order for Gazelle to have any chance of reading a Python file and writing the correct deps into the build file. Right, and maybe let's do a quick demo of that. So let's say we go to the main Py just to illustrate the point, and I want to import YAML. Is that what I do? And then I do Bazel run Gazelle. And what I expect to happen is my build file now has @pip//pyaml, because that's the pip package that Bazel needs to include into the compilation or the runtime environment. Technically, it's the run files in this case, in order for the thing to work. Okay, I haven't made you write a build file, right? We didn't have to learn about PyBinary in order for this to work, because Gazelle is pretty full-featured for Python, especially if you're willing to follow the conventions that it works well with. There are a few directives you can use to influence, for example, do I want one Py library for each directory? Do I want one for each file? There's a little bit of stuff you can play with there. And it also supports testing, which we will do. Okay. So let's see how much I followed my own structure here. So we grabbed the request package, we put it in the pyproject toml file, and we ran a compile step. It so happens behind the scenes when we ran the compile, we were using UV already just to do the compile step, but it was still producing the old, leaves much to be desired kind of lock file. right? And then in the requirements folder, we have several requirements files, which we got by running repin, and then the pip parse, which is in the module.bazel file, reads that. Then we ran the build file generation with Bazel run Gazelle, and the content is updated, right? So that is how you can do Hello World with Python and Bazel. Any questions so far?
Just
Yeah.
one. The Gazelle YAML, it's the only way, or directives is also supported? Command directives instead of the YAML? Just curious.
I didn't quite understand, but we're talking about
Yeah, I mean, like,
this.
say, for example, to resolve the YAML, you give a hint to the YAML, say, YAML, please spy YAML. Gazelle also has like the command directives that we can put in.
Yes. Okay. So the Python Gazelle extension knows to read this file. So that's how it knew this mapping. If there was a mapping missing here, yeah, Gazelle also lets you put a pound directive in your build file that says, oh, if you see this import, actually it comes from over here. There was no way for you to know. There's obviously also, you can import a bunch of symbols that come from the Python standard library, right? You could import OS. You don't have to put that in this file. And so the Gazelle Python extension also has a list for each Python interpreter version of what built-in packages it expects to be able to import from, so that it doesn't have to add a dep, right? Because it expects that for your given Python version, that standard library is available without having to declare dependency on it. Okay. Yeah.
About the repin script, would there be a way to bootstrap it into Bazel? I see like there's a Bazel ENV in there. Would there be a way to like include it in how it resolves the whatever's on file before it does that wrap?
Yes. So the question is about the env file here, envrc, and how you can put things on the path. And for the moment, let me just answer by saying, yes, we could put repin on the path. So instead of typing /tools/repin, I could just type repin. And maybe we'll do that in a minute, but I think I should do it in the order that's on the slides. However, like behind the scenes, we still have to run these steps. Yeah, I think maybe this is a good time to explain one more thing here. So we have line 6 and 7, right? So we're running Bazel run update on 2 different requirements targets. Why do we have to do that? Why can't we just update like the one lock file? And the reason is that we're using a layered requirement setup. So I'm going to open the requirements folder. You can see in the README. So this requirements folder is at the root of the monorepo, but you could have subdirectories that want to bring their own dependencies, right? And that's already supported here. We will do that. We're going to split up our dependencies by the ones that are runtime. They need to be included in whatever artifact we ship. You know, it could be a PEX file or a Docker container or whatever. And then we're going to have some that are only for testing, so we don't want those to ship. We have some that are just tools that we use during the build and then aren't even inputs to any test actions. And the strategy we're using here is not a Bazel invention. You can go read about this on pip tools. It's called layered requirements. And basically the idea is like some file says, I need Django, and then some other file uses either a -c, which means constrain the solutions to match that other, to be compatible with that other file. So -c is kind of like be compatible with. Right, and then so you compile that, and then you can compile some other file that depends on it, and that's why there's 2 steps in our repin, because we're gonna build 2 different requirements files, right? So here's runtime.txt. If we look at all.in, this is where we stitch them all together. So the -r is the other common line you'll see in a requirements file, which is just basically -requirements, which is just an include, right? So this file is just saying include these 3 other files. So we're going to grab tools, test, and runtime.txt. These 2 are .in files because the solution for these we're happy to just have in the monorepo layer. The runtime.txt has already been solved because we will want to include that in the container that we ship, possibly, right? So if I'm building a Python package in my repo to ship, I want to include the constraint solved runtime dependencies in whatever package I send to PyPy. Anyway, that's a minor detail. Like there's various opinions about how to do this kind of requirements dance. This is, you know, one thing that I found is a trade-off between not too long and complicated and gives us some like real-world experience with how to manage multiple requirements files. And in a couple minutes, we'll create a new library and it will have its own requirements. So we'll stitch that in here too. Okay, yes, and tools.in has copier. So that's critical. That's what we're going to use next. Okay. Now let's see what happens in the editor. So I said we're going to try to be mythbusters here. So you probably have heard Bazel doesn't let your editor work. And that is because rules Python uses the weird stuff from Google, where they assumed that instead of using site packages folder, you're going to like vendor all of your Python code into your monorepo under / third party. And you could do that. Almost none of us will. So what we want is for our editor to understand what's going on, even though we're using like requirements that came from PyPy, right? PyPI, sorry. So if we look in the in our example right now, what we see is that the main file has requests, and YAML is not accessed. And if I try to click through to where request comes from, I go to some weird place, MS Python, VS Code, Pylance. I am accidentally falling into a location that the editor extension uses requests. This is not my version of requests, right? And it may happen to work a lot of the time, but as we all know, once you're in a repo at large enough scale, the wrong version is never okay. There's going to be some problem where some API is different. And of course, like once we install things that are not in the, let's see what happens if I try to access the YAML package, and I don't know what's the right way to do it. I can probably just refer to the symbol and do nothing with it or print it or something.
YAML.__file.
Ooh. Under YAML? It's giving me completions.
__file. Double query.
Okay, I followed instructions. And again, I so happen to get this from like the wrong place. Okay, so this is not good. How are we going to fix it? So the answer is virtual environments. So most Python developers are going to create a virtual environment as the, because they need a developer environment in which to work that is isolated from other projects they work on their computer, or isolated from the Python interpreter that's shipped with their Mac. Of course, like macOS is no longer shipping with Python interpreters, so you could think of that as being better or worse. And so the virtual env has a, if you've ever cracked one of them open, inside it has like a bin folder that points to the Python interpreter, and then it has a folder called site packages, which the interpreter will use at runtime to load stuff from. And in this case, we're getting Py binary from aspect rules Py. One of the differences between that and rules Python is that it creates a virtual environment. And that's going to make our editor happy. Okay, so in order to make the editor happy, we have to find that virtual environment and load it, basically. Okay, so how do I find it? So first I'm going to do a Bazel query of everything that I've got in my project so far. Right? And again, all I did was like create a couple line main file and run Gazelle. Py binary from aspect rules Py gives you these 3 rules, and one of them is virtual environment. And if I Bazel run that target to create the virtual environment, now I get some instructions that says how to set it up in my IDE. So now if I click on select Python interpreter and I go find that thing, let me see if I can remember the right way to do this. Enter interpreter path, browse my file system, go back up a folder, oops, go back down a folder. Okay, so here is app.bin.venv. Notice we're getting a different virtual environment for each binary, and when we add tests, we'll have a different one for each test. You might, normally Python developers will just make one virtual env that is the union of everything that they use in their whole repo. This is slightly better in the sense that when I'm in this virtual env, I don't accidentally see things that are not in the depths of this binary. So like I'm not accidentally going to see PyTest show up. It's also slightly worse in the sense that I have to pick which virtual env to be in based on the binary or the test that I'm debugging. Okay, so I pick Python 312. And then the editor is probably thinking for a second. And then if I go back to the main and I click through to requests, now I go somewhere different, which is the run files of the virtual env for the package that I'm in. Right? And now in a minute, we're going to bring in some other third-party dependencies. Those will work too. So we fixed the editor by not being weird. And I use the same philosophy for other languages too. Like whatever the editor was expecting to happen is what should happen. Which in this case means pointing it to a virtual env. Okay. And we will do debugging in a minute, which also uses virtual envs. But any questions so far on editor setup? Yeah.
What would you do if you use the standard Python rules?
If you use the standard Python rules, I would expect that your editor is broken.
Oh, okay.
I mean, you know, what are you going to do, right? Like, it creates a run files tree that's not a site packages folder, and the editor has no idea what to look for. You could write your own editor extension. I'm sorry. This is what Google does. I'm sure some companies have done this. Yeah, just like crack open VS Code and Sublime Text and Zed.
Yep. There's two other options. Very recent Rules Python has an experimental mode that will create a site packages tree, so you could try to do surgery to go use that,
Yep.
which is what our PyVen does for you, except we create our own site packages tree using different machinery. And there's also the Rules UV in Bazel Contrib, which does have some other machinery for trying to synthesize a site packages directory using its own strategy. So, like, these are all choices for how you go build a virtual env out of Bazel without just running Python 3-m then on your requirements log file.
Yeah, thank you. Does Reed come across on the audio, by the way, or should I hand the mic around?
If you can like repeat questions, but if he's just sitting there, you can just get it.
Okay. Okay. No, thank you, Mark. Yeah, we'll use that next time. Okay. Yeah, next question.
Well, I was just going to ask, why not create a single virtual environment for the entire transit closure of the rebuild the editor to use?
We should probably support both, and right now we don't. I think it's unclear how to have exactly the same semantics that you would get if you installed all those packages, right? Because like in a monorepo, you could have multiple requirement closures.
Maybe one virtual environment for each closure?
Yeah, I mean, I think you can do that already with Rules VN.
Yeah, so there's a couple things you can do. The short version is what we're doing here to build the virtual environments is we're taking your transitive dependency set from the actual binary and we're just transliterating that into the virtual environment, which means that you will get your first party sources as well as part of the virtual environments, like resolved path, and all of that just works. So if you're using custom import paths or anything else fancy, all of that gets mirrored into the new virtual environment you've just built. But in order to do that, we're depending on your entire source file set, right? So the problem with building a virtual environment that has the like transitive set of everything, like the power set of everything in your repo, is now we depend on the power set of your repo, and this virtual environment gets rebuilt all the time, or at least has an incredibly expensive dep set. There's some discussion of how we can go do that more cheaply. That revolves around trying to do something outside of Bazel to collect all of your import prefixes and then do some magic so that we like generate the right password actually depending on the files and we only depend on your requirements. So you could cook up ways to go have a sufficiently large, you know, like the conventional developer virtual environment and still pull in all your first party stuff, but it is nowhere near obvious, unfortunately.
Is this using language server protocol, or could you use this alongside some sort of language server protocol setup?
Yeah, it is. This is using the editor extension from Microsoft that works in VS Code.
Yeah, it's completely LSP agnostic. You can bring your own LSP, it'll just shake and bake. It's just an interpreter you point to.
Can the LSP select the interpreter that it wants to use, like based on your file?
Yeah, and we'll show that because I'm going to use the virtual env when we make our test target, and we can drop into there. And yeah, I mean, it's up to the editor extension, like how to communicate with the language server protocol about like switch the context that it's in. I also like to point out that the editor is not the only tool that wants to understand your code and be able to follow the import statements. You have things like security scanners. So even like, you know, sort of flippantly saying, oh, well, you can make your own editor extension. But if you don't have a virtual env with a site packages folder somewhere that's like normal Python land, you're also going to be broken for like, you know, jump to definition in like a code browser or static analysis tools or other, like there's other things aside from the editor that want this answer. Okay, we continue. Stay. Okay, so we're going to take a brief foray into watch mode. JavaScript developers all need to have a really awesome fast watch mode. Why do they need that? Because they had it in the past and they got used to it, I think. It's basically the answer. It's not like the fact that your application runs in a browser means that like you can't afford to rebuild it, right? You just refresh the page. So we do have watch mode set up here. It's not part of the Bazel project. If somebody has enough of a like desire to go contribute upstream, like it probably should be. There's a wrapper called iBazel that comes from a separate repo called Bazel Watcher. It's easy enough to grab it and put it on the path, which we have set up here. It takes most of the same command line arguments. And so just to prove that this works, I'm going to instead do iBazel run of the same thing. So instead of Bazel run app bin, I just put an I there. So I got 3b, and then I say plus thing, and I save, and it runs, and I get some other random thing, and I printed a message. So we're kind of in a live, more of a live environment here. You can use iBazel on tests also, which is pretty convenient. You might get, you send your pull request. There's 10 broken Bazel targets. You just do iBazel test on those 10, and just leave it running, right? And then you just start going to make fixes, and in your terminal, you're watching the number of failing tests hopefully reduced and not increasing all the way down to 0, and then you're ready to send it out for review. So I think this is a good point for me to show, okay, iBazel came on the path. How on earth did that happen? I don't want to spend too long here because I did a podcast recording with Fabian, who wrote this great stuff to wrap dir-env. But we looked at this env-rc file for a moment earlier with the question about how things go on the path. So .env-rc comes from this Unix tool called dir-env. It can do things like export a variable. The idea is when you cd into this folder, maybe I'll demo this. So if I cd up a folder, you get to hit Control-C twice for iBazel, power tip. You see dir-env unloading. Sorry, it's kind of at the bottom. I don't know if everybody can see. And then if I cd back into the folder, then dir-env loading, and it exports a variable. So I can basically say, hey, there's certain environment variables I need to be present when I am in this folder in the terminal. The first one is for our Gazelle extension layer called Orion, and it wants to know where to look for Starlark files that add more Gazelle extensions. Not going to go much into that, but I have a talk later in the conference about it. The next section comes from this bazel-env.bzl. So this is a rule set. You can go find it. Thanks to Fabian at BuildBuddy for writing this thing. Basically, what it does is it gives you a spot in a build file, and I put it under the tools folder as a convention. So I load that thing, and then when you call it, you're basically saying, here's all the tools I want to be on the path. I want Buildifier to be on the path, and then here's where to get it. Buildifier comes from at Buildifier pre-built, okay? And that just so happens to come from there because Keith put a module on the Bazel Central Registry, so Buildifier pre-built is in my module Bazel file, and it exposes a label for the tool, right? And so if I want to just run Buildifier on the command line, great, now I can. And Buildifier is for formatting and linting Bazel files. How often do you need it on your path? Not very often. But here's the key. If you want to write some instructions, you want to put a README in your repo that says, oh, if you see this problem, you just need to run Buildifier, blah, blah, blah. Every time you've written that in a README, in the back of your head, you're thinking, oh, what if they don't have Buildifier? Like, I'll have to add a paragraph about how to install it, or link to the paragraph, or just forget it. I'm sure they'll figure it out, right? Our whole goal here is for this to be super reproducible under Bazel, which means Bazel manages the developer environment too, including the path. So I know as soon as I make a change, as soon as I added a line to that build file, as soon as I add line 38, all my developers have Buildifier. And I could do this in the same PR where I add some instructions to a README that says you should run Buildifier. I could script around it, right? I can write scripts in my repo that just assume Buildifier is on the path because I know that it is. You can get things from other places. So like format is a command on the path, right? I can just run format. Like, wow, magic, where does that come from? That actually comes from a label inside the repo. So this just ran rough over Python code, and it ran Buildifier over Starlark code. Copier, we'll use that in a second. That's a PyConsole script binary, which is just fancy term for meaning some package I installed, some pip package I installed, has a console script section in its descriptor file. I don't know, there's a couple different ones. There's like a record underneath a wheel or something. And so this is letting me just run it, right? So I don't have to make any custom PyBinary scripts to run something that comes from the world. I installed the copier program, right? That was in my tools.in. So I said I want copier. And now that I know that I have at pip//copier available in the project, I can put it on everybody's path like that. You can also use tool chains, right? So I have Python on my path. If I say which Python, I have one that comes from underneath Bazel bin. And that is the exact same interpreter that that Bazel is going to be using for my build actions and also for test actions and shipping, unless I do some fancy toolchain stuff so that my target platform uses a different Python than I use during build time, which you could want because you can get a smaller Python interpreter for runtime. Okay, and then there's this pipe, which is just Starlark for add two dictionaries. So multi-tool tools. So rules multi-tool, yet another thing that comes from the Bazel Central Registry, is pretty fantastic. What it does is it lets me just provide a lock file. And it also provides a tool called multi-tool to update this lock file. So I actually, on CI for this repo, I get PRs regularly to update the things in this lock file. So I have the aspect CLI. So that's something we wrote and actually launching a major new version of it this week at the conference. So this is our task runner, so it can do things like format and lint. Buildozer, which is the machine editor for build files, is in here. Gazelle is in here. Now this may seem weird because normally you get Gazelle from the Bazel Central Registry. This is the pre-build of Gazelle. So I'm downloading a pre-built Gazelle for my platform. It has the Python thing already built. And the Python Gazelle extension depends on TreeSitter, which is a C library. And it's just not that easy to get. Like if you have a C toolchain in your repo already, you can get that to work nicely. But if you don't have C++ or C code in your repo, you probably didn't want to have to figure out how to make a hermetic CGO compilation work. This is easier. Just grab a pre-built binary. It includes more languages. And then here's where iBazel comes from, right? So I showed I can just run iBazel on the command line. It's because it's in this lock file. So I have a very convenient way here of just installing tooling in the developer environment, period, right? Whether it's inside of GitHub code spaces like we're showing in this demo, but if you check out this code on your laptop, it will work there too. Okay, so.
Question.
Yes.
Let's say whatever this file is producing a big size. So the container we want to keep it light. Is there any way to cache and put it in local disk and where to save it?
Yeah. Okay, so the question is like, some of these programs look big, and now every time I drop into a dev environment, I have to like fetch them, and like, can I set it up in the base image? Yes, you could. So there is a dev container here for folks who are using dev container, which doesn't have to be everybody, right? Like this setup works even for people on my team who choose not to use that. So this is where I'm doing Bazel run of the Bazel env target. And you're right, this thing does fetch all of those tools. In this case, it's all cached. Wow, this is running slower than I would have expected to check cached actions. Okay, so, and this is nice. It tells us all the things that are on the path. And there's a bunch more stuff in that lock file. You can see here I have like shell check. I have Terraform, like the whole developer environment, right? There is, basically the answer to your question is there's a feature request in the Bazel env repo to be more lazy. So that instead of downloading the tools when I run Bazel env, like it should, add a indirection, and then as I call the tool, it can then fetch it lazily. There's a trade-off, right? Which is, in this case, I know all these tools are actually ready to run. Like if I run Terraform, bam, it's running. If I do it lazily, I run Terraform and I'm waiting, right? And now I have two choices. I could print progress to the terminal, but then anybody who's like screen scraping the output of Terraform is broken. Or I could print nothing, and then it's like, Terraform? Okay, Control-C, try again, right? I don't understand that I'm waiting for something. Probably the best case is for the developer environments. If you actually wanted to ship containerized like remote dev like this, use a real system like Coder or some other option where you can sort of suspend a machine after the setup has already happened. And then, like the container that somebody starts from would have more things already warmed up in it. I haven't tried doing that here yet. It feels like it should be possible. Yeah, question?
You mentioned the aspect CLI being bootstrapped to multiples essentially. So that means you don't, like, usually you need to be, like, underneath that aspect folder, but whatever you want to download. So all of that is managed by.
So there's a couple options. The aspect CLI, Reed was actually one of our engineers, did like a whole rewrite of it recently. And there are a couple options for fetching it. Like one is to brew install. You can download binaries. This one I find convenient for this demo, for this training course, because the rules multi-tool is already set up, right? So it's just one way to put tools on the path. We also ship a launcher that's sort of like Basilisk, but for Aspect CLI, and then it will, that one will say like, which version of Aspect CLI do you want? And then you could manage it there.
The launcher was my major contribution to that.
Yeah, which I was joking we should call aspect ISK, so that it's more obvious what it does, because it's like Bazel ISK.
Yeah. But it provides lint all the same, right? Like the lint command, everything is provided whether you install it through multi-tools.
Right. Yeah. Yeah. All the same commands are available, so it's sort of up to your dev infra team, like exactly how you want to configure. Like this is one way.
Sorry, just double checking. This won't work on Windows, right? The Bazel102.
Does it work on Windows? So I think you should ask like every session at the conference, ask the same question. I have not tried this on Windows. I don't know. Let's look. Durenv Windows, Durenv.net. Like generally speaking, for things to run on a bare Windows machine, yeah, 0 hits. It's hard as long as your developers are willing to install the Windows subsystem for Linux, WSL, and then run things inside of there. Generally, most of Bazel land then starts to work. So.
Prerequisites, Unix-like.
Unfortunately, much of RulesPy has the same problem.
I mean, look, I was trying to make like my awk.bzl rule work on Windows on the flight, and I'm like, oh, look, like the gawk module on BCR doesn't work on Windows. Most things on there don't work on Windows, right? Like, at least we now show on the Bazel Central Registry which platforms it was tested on, and I would love to add like a filter box. It's like, only show me the ones that work on Windows, and how many do you think that will be out of the 800 or so modules on the registry? Yeah, maybe 20, something like that, yeah.
Always double checking.
Yeah, maybe we should have like a Windows special interest group, and some companies can help fund all that, because there's work to do for sure. Yeah.
Do you need to run Bazel run tools during on like every time you open up a shell, or does it modify like your bash RC or something like that? How does that work?
So when you install Durenv, it puts a hook in your shell.
Okay.
And you actually see that in the dev container. We do Durenv allow. No, sorry, it's in the Docker file. So we did this step. We just put eval Durenv hook bash into the global bash RC.
Okay, thank you.
So yeah, that's the magic missing bit I didn't show. Okay, cool. So we have a developer environment, and we'll use it some more. Okay, doing okay on time. We could go faster, I guess. So yeah, everybody who needs to go, there's another session starting in 10 minutes. So far I've just like shown one hello world file. Seems kind of boring, doesn't look like a monorepo. Let's fix it. We're gonna add some more libraries to our app. Okay, so we're in a trunk-based, like first of all, like our whole point, part of the point of using Bazel is that we want to have, if not a mono repo, like you could have more than one Git repo, but you want this property of everything is live at head. So I make a change to my Python library, and then I don't have to do a release and like get my customers to update a version in their requirements file in order for some application that uses my library to get the change, right? Trunk-based development, live at head. There's no bump version, there's no like sending Git tags, right? So to show that happening, we're gonna scaffold out a library. So I mentioned we have copier on the path already. I made a little, just both to demonstrate copier and also to save some time, I made a little template library. Probably, your organization might want to have something similar so that, engineers who are starting a new service are following the organization's conventions on what's the right files to have inside of that new service, right? So I'm running copier copy on this thing, and the last argument is mylib, which is a folder to put the result in. And so it copied some files in there, and then we can go look in that folder. In this case, the template came with a build file. Doesn't have to. But there's some commented out stuff here that we're going to want to be able to access. It comes with its own pyproject.toml with its own dependency. Depends on cowsay. Very powerful library for anybody who's in the agriculture field. You probably already know about it. Like most big dairies are using this now. So yeah, we're going to depend on cowsay. That means we need to include this in our monorepo dependencies because the all.in file that we're handing to pip.parse doesn't have that library yet, right? So yeah, let me make sure I do the things in the order I said I would. Okay, so we need to, there's also a transitive dependency that this thing brings in from the Bazel module file. So like there's a, let me close some tabs. Right, so there's a JQ load in here, and JQ wasn't in my project yet either. So the first one of these I'm going to solve for is I'm going to run bulldozer. Partly this is to show, yeah, bulldozer's on my path. Like I said, I can put this in my instructions because I know you have bulldozer on your path, and it's the right version. It also is going to modify the module.basel file. So anybody who's used Bulldozer to modify build files, you may not be aware, it can also update the module Bazel file. And this is much better than me like giving some prose instructions. It's like copy and paste these things because, you know, out of 500 developers in your org, 5 of them are going to type the wrong thing and ask you on Slack, right? And our whole goal as developer infrastructure is don't ask me on Slack. Sorry, to make things reliable for our users. So yeah, so I just run those 2 commands blindly and my module file is fixed. Now it has JQ. I don't even bother looking at the result. Do we look at the result? I don't know. I guess it's,
You should uncomment the line.
it's satisfying. Yeah, so JQ just got added here at the end of the Bazel dep section. Pretty good job that the Bulldozer tool does of deciding where to make the edit in this file. Thank you to Fabian and some others who worked on that. So yeah, to Reed's point, we can uncomment this. We don't actually need it yet. Okay, and then the other thing that my dependency brought was cowsay. So I think for the purpose of time, I'm not going to get into the question of how would I have multiple transitive closures yet. Maybe we'll save it for later if somebody needs it. I'm going to assume that I want to add this to the one monorepo transitive closure. So I need to add a -r line to the requirements all.in, which is where I stitch everything together. And then I need to run Bulldozer to add that to the data dependencies of the UV pip compile step, because that's just a Bazel binary that wants to know all of the things that it's going to need to lock. So I'll run Bulldozer again to add mylib requirements to the data deps. Then I just do /tools/repin, which is that command that's just a little bash script that wraps the 3 updates. So it updates the runtime requirements. Then it updates right now it's updating the Python Gazelle manifest so that it will know which package provides the cowsay import. Checking cached actions.
Sorry.
Yeah.
What's the difference between before we did Bazel run requirements runtime update instead of the just adding in the requirements txt or?
So what happened here is just I needed to make a couple edits in the requirements folder. One was to add the mylib requirements as a data dep, and the other was to stitch it into the all.in file that says this is one of many sources of requirements in my monorepo. But like the team that maintains mylib still owns their own dependencies, right? They get to put this in their own PyProject YOML file. We're not making them be weird. Yeah, and then that repin script again was just simply a wrapper around the fact that, in this case, I could actually skip this first one because I didn't edit runtime deps. I think I edited a different one. Okay. And so now cowsay got added to our all.txt file, which is what Bazel's going to use. So now that I've got a library in my repo, now of course I want to use it. So now we're going to have a cowsay this thing. So I go back to my main that we were working on earlier, replace all of the code with this, and run the binary again. I could type, but it's dangerous to type in front of people. Oops, I indeed ran the wrong thing. Okay, so I got an error, no module named mylib. So, you know, we're used to seeing errors. Why is that? It's not in the depths of my application, right? All I got to do is Bazel run Gazelle. Mylib is added to my depths. Notice it removed the unused YAML one, which I deleted the code for that. Now when I run the program, we have Marvin saying 6F. This is a good opportunity to mention we've got these little booklets that have the Marvin character, and on the back you can scan a QR code to get a plushie, and I will mail it to you because I need more space in my garage. Yeah, so anyway, it's not actually a cow, sorry, I misled you. But yeah, he says a thing. So that's cool. So what did we just do? We grabbed a library using copier to stamp it out in our repo, and we wired it into our app, and it is working. Now let's do one more thing because we want something a little more interesting. We're going to grab a Python service because I don't want to depend on the http bin.org being up. So copy one more of these. This time you can see the 3 files I got. I grabbed a library that's not Bazel aware, right? Like some project in my company is not. They're like, you Bazel people are crazy. And we're like, yeah, we know. So I can still use this project, right? All I have to do is import it. So where did I put this thing? Into my service. I forget if I gave myself a cheat sheet over here. So I didn't, so we'll have to figure this out live together. So we'll do something like from my service. Notice my editor's happy, right? I'm getting completions. Import, I don't know what it is, service, I guess. And then this is like service dot something. Service dot main, get random byte. That sounds like what I want. So, and maybe we'll print that instead. Right, and now all I have to do is Bazel run Gazelle. Okay, now notice my service is sitting over here, it's bare. It's got a requirements file, which happens to depend on Fast API and UVcorn. So this is going to be broken because I haven't stitched those into my repo yet. Let's see what Gazelle does. So I get a failure, not surprisingly, because my service is an invalid dependency, because it can't, it didn't generate a build file in there. And so the answer should be go to tools, requirements, all.in, add the -r line, my service, and the build file. Notice that this is not going to work yet because there's no build file at all. So I do have to do a sad bit of bootstrapping where I write a build file by hand like a farmer with like a file group. Something like that. Okay, and then I run repin. Hopefully this is just boring. It's not visible. I could do dash just no check visibility, but let's pretend we care. Visibility is, and I mean, like in theory, part of the reason we have a requirements colon package, and that needs to be an array. Oh, hold on, stop the presses. I'm getting help from the editor that tells me that that needs to be an array. How the hell did that happen? Okay, so I glossed over this earlier, but I'm glad this popped up. There is a language service for Starlark from Withered Magic is the GitHub handle. That fellow seems pretty nice, or I don't know, whoever they are. And I've installed that in rules multi-tool. Okay, so part of that lock file I showed you earlier, tools.lock.json, somewhere down here has star polls. So that's a language service for Starlark. And finally, in my .vs code folder, in my settings, I point to that LSP command. And notice this is one of the nice things about this Bazel-env package. It gives me a stable path to this thing. Like you might notice this is not like K8 opt or Darwin fast build. It's got its own transition into a different Bazel output location so that this path stays stable. So my editor can rely on this as well as like SDKs and other tools. So like Buildifier is also coming that way. So yeah, that is super handy. So now if I add the array, it works, right? And probably I get completions. Some of those look valid. Some of them don't. But yeah, language service, like I should be able to hop to the visibility attribute. In this case, I don't know for file group if it takes me anywhere, but you can see here, like I can get the hover of like what's in file group. So cool, okay. We run repin again, this time it's happy. It's slow enough to drink coffee? No, it's not. Bazel run Gazelle. Okay, so why am I still sad? I didn't actually rehearse this part, so we could just skip over it. It's not essential to have this working. We definitely can check that our all.txt has UVcorn. Okay, so click came in from that. So like we have this library. So does anybody feel like prompting or hazarding a guess as to why my import statement does not work? Ooh, I think I know. Reed, do you have a guess? I think it's imports equals, but why would that affect Gazelle? No, it doesn't work. Okay. It's fine. Let's keep going. It's the same idea. We've already saw it work once. Okay. So another thing that you might think doesn't work in Bazel with Python is debugging. So let's make a test and we'll debug it. So we're going to use PyTest. We will test our original library. So this is where the cowsay happens. So I'm going to make mylib / say test.py. In this folder, say _ test.py. Notice I'm following a naming convention here, which is important for Gazelle. If I just decide to name it something weird, it's not going to work. Now, this happens to use PyTest, but of course, PyTest is some magic global that just gets inserted into the runtime and you don't import it, so we'll have to deal with that. And yeah, so we'll debug this test. So first of all, let's run Gazelle again, and I guess I'll just delete the my service. And I'll probably have to delete it from somewhere else, but let's just see if that works. So I'm going to do Bazel test for the first time. No, sorry, I need to do Bazel run Gazelle. Okay, I got to fix the main. Okay, so now I should have, under mylib, the near the bottom here, I have a Py library, and now I have a PyTest. Now, what happens if I run this test with Bazel? Okay, it fails. And does it fail for the right reason? Looks like it. Assertion error, assert none equals intentional, blah, blah, blah. So the thing I put in this file was intentionally wrong. So if I want to make the test pass, I would put none here, because that is, in fact, what the return value of the say function is. Stupid test. Obviously, we wouldn't test this function. But, you know, maybe we're supposed to get test coverage in our repo, so I have to have this test. OK, cool. So our test is functional. Let's go back to having it broken and prove that because I have a virtual environment, my debugger should work. Okay, so let's once again do a query of mylib : all. So I have a say test.venv, so I can run the venv target to create it. I can tell the editor to switch there. Go up, find the one that's my test, right? Bin / Python 312. Okay. Now I should be able to debug this test. I don't even have to be inside of Bazel to debug this test, because my virtual env is set up so the editor's debugger should work. Okay? So all I have to do is go to my tab here, configure tests. So because it's a magic global, like the editor has to ask you which test framework you're using, find a directory that contains the, oh boy. Let's try pressing the right button. Mylib. Okay, and then, I don't know, something like run all. Cool. Okay, it failed. And then if I want to debug, let's put a breakpoint in the library code, which is say.py. So cowsay, go back to the tests, press debug, and I hit the breakpoint, right? And I can see what the text is, and I can do all the things I'm used to doing in a debugger. So because we have a virtual environment, debugger just works. I could actually also go into the terminal and activate this virtual environment. Let's try that for a second. So I can do to activate. Thanks for adding this message read. Okay. So I think that activated it. Didn't change my terminal. Let's see if I can go into my lib and run Python 3, I guess, -m pytest. Any guesses as to what's going to happen? Cool. Right. So the whole point here is, by not being weird, we've also avoided the classic Bazel foot gun of forcing your coworkers to switch to it. They can still just do things with PyTest, right? Nobody has to switch to Bazel. We're going to make Bazel so great eventually they choose to. Like, that's our job as developer infrastructure, but we shouldn't force them. Okay. Cool. Any questions on debugging and testing? How many of you expected the debugger to work? I showed Reed this a few days ago. He was surprised the debugger worked, but yes, it works.
And I own that pen rule, so.
Yes, we're very confident. Yeah, okay.
Question.
Yes.
Could you make that debugger work outside VS Code as well on that environment?
Yeah, so the question is, can it work outside VS Code? So there's two moving pieces. One is I did Bazel run on a venv rule that works anywhere. It creates a virtual environment. And then whatever editor you're using has some way of saying, I want to run tests, and you just need to point it at that virtual environment. Everything should work. So like PyCharm should be trivial to show the same thing working, yeah.
Yep. Same exact thing works in PyCharm. Same thing works in other more exotic IDEs. You just set the interpreter home.
Okay, cool. So the next thing I want to show you is code generation. So far, what commands have we run? We did Bazel run of a binary. We did Bazel test. You know, implicitly behind the scenes, we did Bazel build. That's kind of boring, especially for Python because it's an interpreted language. So the next thing that people often need to do is introduce a code generator to their repo. Either it's a generator that you wrote or it's a third-party one. So to motivate this part of the example, here's what we want to happen. We're going to generate a header because we're shipping our new Marvin Say application to production. So we need to productionize it a little bit. So what we're going to do is we're going to add a header. It's going to have a version stamp, and then it's going to say like, you know, who built this application, what version it is. So for that, we want to do a little bit of templating, right? We want to have a header file that we can fill in some bits, and so we're going to use Jinja as our templating. So we're going to add Jinja2 CLI to our requirements in file. The tools in file, which we haven't touched that much yet. How do I make this stuff go away? I don't know. Oh, I probably go to the debugger and I hit end. Stop. Okay, that's better. Okay, so tools.in, so we're adding a second tool. Okay, now we need to do our normal dance of repin, right? To solve our requirements. Oops. And I still have my abandoned attempt to add the service in here. And it's probably still in the all.in.
Deactivate.
Yes. Good thing we rehearsed that part.
That bug's fixed in most recent rules pipe.
The one that's sitting in a PR on the central registry. And then I have to do something Bazel
Unset Python home. One word, no underscore.
Okay, always have read in the front row when you're working on Python.
Oh, Python executable, sorry. I'd be happy to go into nauseating detail about what this is and why, but
Yeah, no, I think we have a few more hours, so we should definitely get into that after the...
no.
Okay, there we go. So now we're running UV, we're re-locking our lock file. Okay, so the next step so now Jinja2 is in our project, we repinned our requirements. So the next step is we just want to put it on the path, right? So basically we do exactly the same thing we already had here for copier. So we're just going to do PyConsole script binary again. This is a rule that comes from rules Python. So I'll call it Jinja2, and the thing here is Jinja2 underscore CLI instead of dash, sorry. So now we should be able to run it. Or we could put it on the path. It doesn't matter which one we choose. I guess for right now, I'll do the quicker thing. And it prints at CLI help. Okay, so anytime we're integrating a tool with Bazel, this is really the first step is you just want to see, number one, like it works, right? Like I can run the tool. Okay, so like we've bisected away a whole class of problems I might have had if I did that wrong. But also, this is our cheat sheet for what we need to put in the gen rule or the custom rule or whatever we want to do with this tool under Bazel. Because Bazel just runs subprocesses as their CLI intends, and so you're always looking at the CLI help. So we're going to want to set a couple of these things. So we might want to set like -- format. We definitely are going to want to set -- out file because when we run this under Bazel, we want to be specific. Like Bazel needs to predict where the outputs of an action are going to live, right? And we're going to run Jinja2 inside of an action because this is like a code generation step. Okay, so, right, I also left myself a note here that we should definitely set visibility again. Maybe for the tools package, we really want the whole package to be visibility public. Oh, it is, okay. Great, I already fixed that. So now that we've confirmed we can run it, what we want to do is declare some code generation. So let's look around in mylib. We already have a template for this header, which I did to save some time. Okay, so here's the template. So it's built at timestamp, and it says I am a cow, but let's fix that because Marvin is a robot. And so we want to run this as a build step, and so of course we'll look in our build file, and we have a, let me make this bigger. So we have this little block that's commented out. So let's bring that back in, just again to save time. So the first thing we want to do is we're going to run JQ. Sorry, pressing the wrong buttons. For stamping, we don't need to do stamping yet, sorry. What we want to do is do a run binary, okay? And the tool we're going to run is //tools : Jinja2. Run binary is basically what you should use instead of general. Every time you want to type general, you should use this instead. For several reasons, general is broken. This constrains you to actually running a single tool, whereas general is a bash 1-liner that becomes a bash 30-liner. And our version, the run binary from the Bazel lib repo, also allows you to produce a directory as the output and several other nice things like stamping. But you can see here we're just doing -- format JSON, like pretty simple usage of this tool, but we're going to run a Python tool. Now, also important to note that like a lot of us come from a background where we're in a repo that's one language, and so, okay, our repo has Python, so that means we can't use tools written in Go or Rust or whatever. And likewise, people who are working in some other languages are like, well, we can't run tools from pip, like that would require us to set up Python. But like one of the advantages of Bazel is like you should be able to run Python tools in any repo, and I should be able to reach for tools written in any other language and plop them here, right? So it's divorced between where I got the tool and the runtime that it needs and how I'm going to use it as part of my build graph. Okay, so we should be able to build, right? This is a buildable target. mylib : make header. Missing input file data.json. Okay, so that's this one up here, right? So the first step that depends on is we're going to make a JSON file. Now, this is going to use Bazel stamping. I won't spend too much time on it, but basically JQ, along with a bunch of other rules, can be aware of the -- stamp flag. When -- stamp is turned off, you want to have cache hits. You want your build to be reproducible and deterministic and all the things we tell people that Bazel is. So that's what this unstamped bit is. So if I build this target right now, what I expect to see, and cat Bazel bin mylib header. So I have built at unstamped. And if I was to do this build again with -- stamp turned on, then I'm going to get a non-deterministic output that talks to the version control system. And now I have built at a timestamp, right? I'm not going to go into a lot of details about stamping, but like you should be careful to keep your builds reproducible. And if they're not reproducible for a specific reason, don't let that sneak into your regular CI process, right? There are some Bazel rules that do it wrong because the rule author API for this doesn't properly constrain you to prevent you reading the stamp files when the user did not say -- stamp. And so some rules will read the stamp files even if you didn't ask for that. You know, we should fix those. Okay. So finally, we want to use this header in the app, right? Because our whole point was to have it wrap. So we want to add a dependency on that code gen. So if we go back to the main, if we go back to the mylib, I keep doing the wrong thing here. So there's a stamped version of the program that's going to try to read that header. So this is the header we just had. We could use the run files library here, but it so happens as long as you can rely on the run file symboling tree being created, you can also at runtime just kind of skip it as long as you carefully identify what's the right location, right? And in our case, the location is the dir name of this file and then the workspace. So probably run files is the more principled thing, but trying to keep it simple. So we go back to our app, and we are going to use that. So say.stamped. Again, my completion is working. And this should be mylib.say. No, sorry.
Should just be a string.
Oh, I need to pass X here, right? Yeah, sorry. I forgot what I was supposed to type. x.encode.hex. Okay. The danger of live coding. Okay, so now what should happen if I run the app? Well, there's going to be an error because it's a live demo, and also it's slightly intentional. How many times do you keep hitting up enter and you're like, I should stop hitting up enter, but I know it's going to be real soon. Okay, so there is no encode. Okay, you're right, it's just a string. Okay, so no such file or directory. So this is where Gazelle is not going to help me because I have a data dependency on this thing that I did not plumb through. The data dependency, however, where does it belong? Let's remember our symmetry in Bazel. So the build file should always mirror the source file. Okay, the source file in this folder knows nothing of this data dependency. The header.txt doesn't appear here, right? So it would be wrong for me to put it in this package, even though it would make it work. So the right answer is say.py is the place that has the import, and so that's the place that needs the data dependency. Tools, colon, do I remember where this thing lived? No, it's just colon header in this folder. No, it's not. Make header.
Dot body.
But I didn't need that before. Hmm?
Those tags are
Oh, I put them backwards?
Text. not-
Text. Thank you, thank you. No, it's not a function, is it? Wait, I should get help. Yeah, okay. I'm sorry, my completion is working. I should be relying on it. Okay, finally. So Marvin says, I'm a robot, I found this on the internet. Okay, so we wired up code generation into our build. We didn't need to do any weird PyBinary steps. All the tools that are published to PyPy you should be able to just use, provided that they give you a CLI that allows you to set things like --out file. Even when they don't, there's always some sort of workaround, and sometimes it's hacky, and sometimes you wrap it with a script, and sometimes you replace the main entry point and you just write your own dundermain.py for the tool, and it's just a few lines, and then you immediately reuse the tool as a library. So there are a couple cases where Bazel sort of forces you to do that. For example, source files are read-only by default under the Bazel sandbox, and so like if tools are trying to do something weird, you may have to fix them. For the most part, they just work. Okay. Now, we've been getting a warning all along that I've been ignoring about formatting. I mentioned that astral.sh has this tool rough. We've already got it wired into this repo to give us both formatting and linting. So in order to motivate this part, let's introduce some more issues. Okay, so okay, I think I see what to do. So I'm going to make a bad format string. So I'm going to be like, okay, we're going to replace HTTPS with a scheme. I'm going to intentionally forget the close bracket, format HTTPS. I'm going to make an unused import, like import OS. I'm going to make a formatting mistake, so I'm going to use single quotes here and double quotes somewhere else. Okay, so now this represents code that people in your organization would really write, or actually, let's be honest, Cursor wrote it for them. And so we want to be able to do formatting and linting, and these are things that should just work under Bazel. So warning for this section, I'm showing things that are tied to the aspect CLI. You can do it without that too. It's not the only way to do it. So I mentioned that there's a format on the command line. That's going to try, so I can run basically a meta formatter across the whole repo that understands all the languages in my repo. That formatter lives under the tools folder. It is, under tools/format. So I have this format multi-run. So rules multi-run, Keith wrote that, it's on the BCR. We're just using it to say, okay, like for each language, and there's a mapping of like what extension. So really, for .py files, I want you to run rough as the formatter, and for Starlark, I want you to run Buildifier. And if you look at the template repo I mentioned at the beginning that generates all these starters, there's like 20 languages in there now or something. C# and F# we just added this week. But I don't want to format all the files, I want to format the changed files. This is not a Bazel dependency graph shaped problem. I did a talk last year at BazelCon about it. So I'll kind of skip most of the detail. The answer is, how do we have this set up in this repo? So there's two things. We have a check config.sh, and every time I've been doing a build, if you were seeing this error go by, or warning, that's getting printed from this thing. This is wired up as the workspace status command, which is just a gimmicky way to get Bazel to print this on every run if it's not happy about the status of my workspace, which it's not because I haven't said how I want to set up my hooks. What I want for formatting is when I make a commit, it should just get formatted. So there's two things, there's two instructions here. One is to disable the warning by opting out of this, basically put it into my personal Bazel RC that I'm not interested, thank you. I'm going to do formatting some other way, or I love the way my code was formatted and I just don't want you to touch my code. Probably on CI, somebody will set up a thing that stops me anyway. The alternative, and what most users should do, is run git config. And so that adds pre-commit to my git hooks, and this is where it's going to do a Bazel run format, but only on the changed files. So it's just going to do a git diff, pretty simple. And so this means that now if I do a commit, I forget if I did an init. Demo code. Okay, so I got an error from the pre-commit that says some files were changed. I should restage them. And if I go look at my main file now, oh, interesting. It changed one file at a time. So if I do this again, oh, why did I not format my Python file? That is not what I was expecting to happen. It did reformat my build file, which is nice. Anyway, let me take this question.
I was just going to say, we have hooks in place to like format code after it's saved in the editor. We've also tried like post-commit hooks. One of the problems we've run into with getting Bazel involved there is that the overhead of like running Bazel and having to do analysis and all that stuff is way too high.
Yeah.
It's kind of hacky, but we've just been like having it point directly to like the formatter binary in like Bazel bin or whatever.
Yep.
Do you have any like? It seems like you're just invoking Bazel as a hook. Do you have any like suggestions on how to fix that?
Yep. So the question is basically like, are you going to wait for Bazel over here in this format hook? Yeah, that's not great. You can kind of like a first step would be to add -- no allowed analysis discard, which would be like basically fail if it's going to be extra slow because like the flags didn't line up. That's still not a great answer. I agree for the most part. What you would want to do is have the multi-formatter already built. So in the same way that Bazel puts it on the path. And I do have it on my path, right? If I say which format, I did already build it. So it would probably be better for me to, in this repo, like I can assume that this already exists. And so yeah, I think you're exactly right. Like this would literally go here.
Oh, okay, gotcha. That's nice.
You also run format. I mean, put the path there.
Oh, it's because I didn't add my Python code. Okay, there. Now I got the thing I expected, right? Which is, it shows me what edits it just made to my Python code.
But could you say the name of that analysis flag again?
Oh, -- no. Sorry, let's just go to the flag dictionary on registry.build and type discard. So it's -- allow analysis cache discard.
That is nice, although I expect it'll error a lot because Bazel is terrible at caching analysis.
Well, if this flag gives you an error, it's your fault because you passed different flags to this invocation of Bazel than you passed last time and caused the analysis to be discarded. Now, if you use coverage, you have no choice because instrumentation filter is a analysis cache buster and changes it on every run, which is why you shouldn't use Bazel coverage. Yes.
Oh, I was just gonna say we don't change flags often, but like every single time, like every day I go to run like I go to run like query the whole repo or something like that, it always consistently takes like a few minutes, and that cache only ever seems to last like 20 hours.
Okay. So the question is, why does my cache go away after 20 hours? The answer is by default it goes away after 2 hours because there's another flag for how long the Bazel server should stay running, and the analysis cache is in the JVM.
Can you not save analysis cache to disk?
Not yet.
Not yet, but go to the talk by Shahan about analysis cache, not only local but remote caching, so that you can warm up the next Bazel JVM with the analysis that the previous one did.
That is
And then we can stop making firecracker VMs and all kinds of crazy workarounds.
okay. Thank you.
Yeah. Oh, it goes deep. I mean, we could definitely stay here for hours. Yeah, there's a server timeout. Idle server, idle. That's like an idle flag or something for making it take longer.
You just scroll past the max idle sex.
Max idle sex. There you go. Default 10,800. Okay, now you know.
I'm sorry, what was that talk you were talking about?
There's a talk, Shahan from the Bazel team, I think it's tomorrow afternoon at like 3 or something like this.
Okay, thank you.
Yeah. Sorry, I forget the title of the talk, but I think you'll probably be able to find it. Something about like caching analysis. Okay, cool. So formatting worked. So as I was saying, like we got a red X here. It did indeed fix those mix of quotes that I put, right? And so now if I do a commit, I'm all set. So this is a developer workflow, like you said. We've fixed it already, right? So I'm no longer doing Bazel run. I'm just running a pre-built binary. Whenever I make a commit, I am here coupling the fact that you must have now set up Bazel-env, right? And probably like, here, let's live code this thing. The right answer is check if this exists, and if it doesn't, then do Bazel run. That's probably your best solution for this file. And we can go update it in the template as soon as we're done here. Okay, so that's formatting. The other half is linting. So linting is very different from formatting. Linting might want to see the dependency graph, and therefore it should be run as actions. We want it to be cacheable. Formatting is always fast, and it can run over changed files. Linting can't run over changed files because I can change file A to introduce a lint warning in file B. And so, so this time we're going to run it as part of the action graph. Now the nicest way, and this comes from the aspect CLI. I can do aspect lint. By default, it's going to do ... and you can see what aspect lint is doing is it's really just running an aspect. Haha, it's also the name of our company, over the graph of PyLibrary targets, running rough on them, gathering the results as report files during this aspect that visits the tree, and then my CLI tool just reads the resulting reports files and prints them. And in this case, the implementation of this comes from rules lint, and this part is new this year. Instead of it being a shell script, we wrote it in Starlark, using the aspect extension language. And syntax highlighting to come. GitHub says they won't syntax highlight this until we have 2,000 uses of AXL files, so please go add AXL files, and then they'll accept my PR, and then this will be syntax highlighted. AXL is just our Starlark extension, the same way BZL is for the Bazel standard library. We have our own standard library. And so you can see basically what's happening here is we're just doing a Bazel build of ... with an output group selected. And if it's an interactive session, I ask for the human output group. Otherwise, I ask for the machine output group. And then I'm watching the build events go by. And this is just the normal Bazel build event stream. So if it's named set of files, I check what file name it is. And if it's one of my reports, then I just print it to the output, right? CTX output right. But it also can take the patch files that come out of those aspects. So the aspect visits the tree, it visits a Python PyLibrary target. It says, oh, rough actually has a suggested fix. It runs rough and then just does a diff to gather a patch file because we don't want to actually make changes during a build, right? The build is supposed to be idempotent. So if I run this with -- fix, assuming everything is working right now, one error was fixable with the -- fix flag. And the other error is not. So it should have removed my unused import, and demo not happy today. Let's figure out why. That is brand new stuff. So like, it should automatically fix that one, right? And then if I run it again, it says this one I couldn't auto fix. So it's reporting the error. We also have on our platform an easy way to take these reports and show them on the pull request. So I send the pull request. That's the place I wanted the linter to report. It's kind of like a robot code reviewer. Yeah.
If you create 2,000 hippos, will they that use this, they will accept as well?
If I create 2,000.
No, just kidding. If you create 2,000 hippos that use your AXL, GitHub will accept your.
Oh,
But,
yes, they will. Please create AXL files.
The AXL is a vanilla native Starlark or have custom built-ins on top? Just curious.
Yeah, so.
BCL flavor, .star flavor, or it's a custom.
Yeah, I've never seen this before. I'm really curious.
Yes, so come to my talk.
Sure. Okay.
Yeah, I have a talk specifically about this, but basically this task bit at the end is the magic. So Bazel has rules and macros, which run as part of the graph and produce outputs. This task runner can run outside of Bazel. It looks very much like a rule. It takes an implementation function. This is the command line argument. So like the reason I was able to, I reported this bug and they didn't, I remember now. Demo's gonna work. Demo's gonna work. -- fix equals true. Really? Shaheen fixed it, I think, already. Okay, there you go. So that, yeah, Boolean flags fixed it in the latest version. So yeah, anyway, we wrote a new thing that surrounds Bazel. It's written in Starlark, but it can call Bazel query, and then it can take, and it gets the results as structured data in Starlark structs, and then it can use the result to do Bazel builds, and like so much stuff you can do.
So create on top of Starlight Forest. I'll see your thoughts.
Yeah, yeah.
I was just going to say, does it make using the build event protocol not a massive pain in the butt?
Yes.
Well, you see, I've used the build event protocol right here to find out what outputs came out of my build and then do things with them, including patching the results into my source tree.
I'm going to go to your.
And if you've ever read Starlark, then you can read this.
Yeah.
Yeah.
If you go check out the Aspect CLI repo, you can find a half-baked implementation of a custom build UI I'm working on that does nothing except pull the Starlark build stream from Starlark and do all the UI drawing and inference of where your build is at on the Starlark side.
A BS? A BBS, event service, like
Yep.
why?
Yeah, and it multiplexes, so the events can still go to a remote backend as well as being processed locally in the CLI. Yeah, we've got a new marketing page for AXL, aspect.build/AXL, but
The aspect CLI in Go, you used to have, I think, aspect 0, right? Like dot aspect something.
yes, so that is still here, and in fact, not strictly part of the demo, but you can see I have a dot aspect/gazelle in the repo I've been playing with, in the starter repo. This is a Gazelle extension written in Starlark that adds sh library, sh binary, and sh test rules automatically from my shellcode. So yeah, and this still lives in the dot aspect folder. Okay, trying not to make it a sales pitch. Anyhow, you don't have to use the aspect CLI. This linting strategy is what I'm really trying to say is when you're using Python with Bazel, you can run the linter as an aspect over the graph. I didn't have to change my build file to mention rough. And I didn't have to change rough or rules Python to teach it that it can run this tool, right? So like that's what aspects do in Bazel. They allow you to just declare, I want this tool to run across my existing graph, not to change it. There was a question in the back?
Yeah, not directly related to Python linting per se, but I introduced the ESLint through the Space CLI.
Yeah.
Like most developers, well, most those that use Windows and WSL, they did report that linting through ESLint was like remarkably slow, which didn't happen on Linux, weirdly enough.
Yep. So why is my ESLint slow locally is sort of the question.
Yeah, they end up using the normal ESLint binary, so I just put in under Bazel NV that like it's on that, but still like it's outside Bazel.
Yes. Okay. So that is the right first answer is don't force anybody. So like if they just want to keep running their existing ESLint, you should allow them to do that. And then between you and me, there's like we should fix whatever the thing. If it's fast on Linux and not on Mac, sandboxing is the most obvious thing to check. Bazel sandbox setup is pretty slow on Mac because it doesn't have the right kernel level extensions. If anybody here works at Apple, we need a couple of fixes in the new FS kit that was released in OS X 10.15 or whatever so that we can use that as a better Bazel sandbox. And like one answer is just use spawn strategy local for those and avoid the sandbox. The nice thing about these being actions, though, is that they are cached, right? So every lint, every time rough executes on a given Pi library target, and you could use this for type checkers too, although we haven't yet, but like somewhere, like Ty is the new type checker from Astral, the same company who made rough. Not quite ready yet, but like in theory, like you want to run that over your graph and as actions, and then they can be remote cache hits. They participate in all the normal Bazel, action semantics and performance bits. And they're slow for all the reasons that actions can be slow. Yeah. Yeah, so there's also Firefly from Meta, which is also a new rewrite in Rust. Haven't tried that either. I think that's also not sort of GA. And of course in Python, like the type specification kind of depends on the type checker. So, when you're adding typing to your code, it may not be 100% portable between type checkers. Yeah, I wish we had more about type checking in this course actually, but like the state of the art is kind of not great. There's rules MyPy, which is probably the thing I would use today if you want to add type checking. It's in Bazel contrib. Rita's helped with it too. We're looking forward to these new tools that are faster and more incremental. Okay. We have one last section, which I'll try to get through with enough time to leave both for questions and talk about the new UV lock file stuff that's coming. And some of this is a little bit broken at the moment, which is basically how do I generate an image target? Okay, so I mentioned that we have this .aspect folder in the repo. And the bit that I wanted to show is not in here right now, which I think is because it's broken. So we'll just skip over that. But basically, like, I can make a Gazelle generator that looks for a comment in a source file and then uses that to know that it should generate some targets. And so I could actually generate an OCI target in Gazelle, even though there's no Gazelle extension for rules OCI. So, you know, I'll add that back to the repo soon, and you can play with that. What we really wanted to have happen is to create a like an OCI load and a platform transition rule. And then when you grab an OCI, rules OCI target, you can build it with Docker. And then you can run --stamp. I showed earlier how to put the timestamp in there. So this is how we would ship our application for other people to use, right? So Docker is one example. You could ship to PyPI. There is a wheel.publish target that comes from rules Python that I worked on. You can publish a PEX file. There's also a few other formats, like there's subpar from Google, which I think is subpar.
Now abandoned, don't use it.
There's SCIE, SCIE is a format. Like, of course, you should expect that any distributable format should work with Bazel, and some of them already do, and some of them we still need to work on. You know, funding helpful. In fact, a bunch of our customers have helped to fund some of this stuff. Boston Dynamics Robot AI Institute and Physical Intelligence based in San Francisco, a couple companies that sponsored Reed's recent work. So super appreciate whenever, you know, there's various ways of funding open source. I'm not going to get specific on the ways that we do it, but you know, if your company needs things, let's get it all upstream. Okay, so as far as the demo goes for this part, like let's see if we can put this application into a container. And because the clever Gazelle thing is currently not functional, I'm just going to go to our Bazel examples repo. If nothing else, I can show how it should work, even if we're not doing a live demo where it does work. Now, rules OCI is a rule set to create layers. Layers are just tar files. And then if you know anything about Docker, like the idea is that the lower layers are big and fat and don't change that much, so we want the interpreter to be down there. Then we have our site packages we want to be another layer, and then our application code, which we're iterating on constantly, should be a layer at the top. Docker is kind of incremental all by itself because the topmost layer has a different digest, but the ones below are the same, then it will leave those alone. It won't move them over the network. It'll be quicker to like rev your production service and not have to wait for the whole thing to load. Also important for Bazel that the Bazel cache would mean that like the base layer kind of sits at rest in the remote cache, and it's only the uppermost layer that changes a lot. So that is already the case here. In this example, and I'm going to try to borrow the build file and see how much of it works. We make a PyImage layer. This loads 3 layers, and you can see the size here, right? So 47 megabytes is the Python interpreter. Again, there is a slimmer one that we have a customer asking to wire up to runtime, and it should be possible. This is the site packages folder, or 3 megabytes, and then 16 kilobytes is the layer I change a lot. So if I do Bazel run on this thing, it will load it into the Docker daemon. And then I can make an OCI image target. And then we get to platform transition file group. Okay, so I'll let Reed talk about this more in the context of UV, but like this is where we talk about cross builds. If I'm on a Mac and I want to make a Docker container, it needs to have Linux binaries. And if I'm fetching pre-built binary wheels, I need to have the ones for the target platform, not the ones for the host platform or the execution platform. That is newly possible. In this case, my application happens to not need that because it's pure Python. So I will succeed at shipping this, but if I had like a Postgres in here, I would trip over the fact that like my Postgres wheel is probably going to not be the one that needs to be inside of this container. But I can select the architecture here, and then like this OCI load will, like if I run this target, this is the thing that actually pushes it to the registry. Definitely encourage everybody to see the talk from Malte about rules image, which is an ambitious set of optimizations on top of rules OCI that like reduces even further the amount of network traffic that has to happen. Basically, like rules OCI kind of assumes you're going to make tar files. In fact, the output from this thing is 3 tar files. Having tar files as the outputs of an action means that they all go into the remote cache, and especially on remote execution, there's a lot of bytes to move around. But it's very simple, so that's the trade-off. Let's see if we can make rules OCI work real quick. I won't struggle too hard. So we'll just try to make an image and get to the point that we can load it, I think. And grab a bunch of load statements. Yeah, let's see how far we get. Try to build app::all. Okay, so we're missing container structure test. That is a handy way to make some lightweight assertions around actually bringing up a container. Rules OCI is missing. We'll go to the registry, type OCI, copy that to the module file. Aspect Bazel102 transitions. That is out of date. That should just be Bazel102, which is another rename that landed recently for 3.0. Aspect Bazel102 has been renamed to Bazel102. Couldn't find Ubuntu. Okay, so that's our base layer, right? So I'm starting from Ubuntu. Notice that this is going to have a Python interpreter in it already. Not ideal. I might want to use a distroless, much thinner, or like an Alpine distribution as my base layer to avoid polluting it with the ability to be non-hermetic. Like we can be very careful in the thing that we ship so that the Python entry point from PyBinary does try to be careful and select the right interpreter. But if a mistake happened, we would fall through to the wrong one. So that also comes from the module file. So we'll go grab one from here that gives us Ubuntu. So this is OCI pull. One of the de-optimizations in rules OCI is that this pull has to happen pretty eagerly, and the base image does end up getting used as an input to certain actions. Again, once that happens once, it stays at rest, but it can be pretty slow and take up space in the cache. Need to use a use repo call.
You're missing use extension.
Yep, I know, I see the red. Okay, we're almost there. And finally, we need use extension, and then we'll see. We'll see how far we get. How many people ship their containers, ship their Python code in containers today? Okay. Anybody else want to volunteer what you're using to ship production artifacts? Or you're only using Python for model training and inference? Don't use it? Code generation? Okay, cool. Okay, so this said hello world app, and the thing is called app_bin. We're close to the point where either it will work or I will give up. Okay, so you see we've made some tar layers. So here's the interpreter layer. So this is really the important part of the talk is for every language, we want to have this behavior of splitting the Bazel graph into heavier, less frequently changing things on the bottom. And here I'm literally running BSD tar to produce this tar output. There's no sort of magic additional tool. So you can see the layers we created. So there's layers, layers interpreter, layers packages, and then layers default is where our code lives. And that thing is 973K. Packages, I'm curious how big that is. In our case, packages is smaller. That would be an interesting thing to debug. I wonder if the right things are ending up in the right layers.
You have a question though.
Yeah, thank you.
If I put two Pi image layer into my OCI image, am I going to have two interpreter tarballs in there? Or will there be a conflict? What will happen?
Two layers, unless they happen to deduplicate to be identical.
You just have two Python applications and you put both of them into the container. Not that the container is a...
Yeah.
Just because you say the developer wants to have some tooling in the container.
Yeah, makes sense. This is another area where rules image has a performance optimization because it lazily creates the tar files. It will avoid two tar files that have the same files inside. So it will save you some bytes in the cache and over the wire. I'm pretty sure the answer with this demo would be you get two actions that run to create the base layer, but if they're the same Python interpreter, it so happens that because it's deterministic, they produce the same output, and so I think action deduplication would save you. Yeah?
Perhaps just after that, I know the JS image layer always creates a node link specifically. And if
Okay, yeah, that's good. So for JS, it's already been observed to not be a duplication problem. Okay. Okay, so we have 12 minutes left, and rather than like, I think I've probably shown enough of rules OCI here to give you an idea. I don't actually know if this code spaces even has a Docker daemon running on it. It shouldn't need to, right? Technically what I could do here is have Bazel push the layers somewhere else and then just hop into like a Docker playground and just do a Docker run on that thing. That's a demo I do sometimes, but in the interest of saving time and sticking with the program, I would love to take some questions, and then we can also talk about how we can do cross builds even better. So I guess first of all, any other like questions, topics generally, even things I didn't cover? Yeah.
I'd just like to, this is unrelated perhaps, but I had an issue with Windows again. Python, for example, depends on Pi Win32, and especially with hermetic toolchain, I was not able to, and I saw only like hacks using like host toolchains to kind of bypass that. I don't know if you kind of saw something similar before, if you know if there is any way like to, with Pi Win32, for example, customization. I mean, I know like Windows is a whole habitual and so on, but
Yeah, okay, so Bazel has this concept of tool chains, and the way it works is that there are certain well-known symbols, that's the tool chain type, and so there's one of those for the Python interpreter that everybody in the world agrees on. It happens to live inside of rules Python, so we will always depend on rules Python, at least for that, and some providers for interop between rules. Toolchain registration is something that you can perform in a workspace file or a module file. The first registration that satisfies Bazel's constraints wins, and a toolchain registration can say like, you know, first of all, I work on only these platforms, and also can have other kinds of constraints. So like the broadest answer is that you are free to register whatever you'd like at that well-known Python toolchain type symbol. And in fact, like one of my earlier employers, we built the Python interpreter as a repository rule, and we pointed to the one that we just built. Like we built it from source. Took several minutes on a cold build. Because we didn't trust the pre-build wasn't good enough, or I forget exactly the details. Then you also, of course, have, I don't know if we still need the screen share or not. I just don't want to have a weird blinking screen. Okay, trees are relaxing. You also have potentially a different toolchain that you want at runtime than you had during the build. And so Bazel's toolchain support has always been a little wonky in terms of making sure that you're registering a toolchain for the exec versus the target platform. And it seems that the consensus is that we just have to have two toolchain types because the toolchain mechanism itself isn't expressing this properly. So there's like a runtime, there's like a target toolchain type and a regular toolchain type. I forget in rules Python if there's already been bifurcated that way. But I think the other part of the answer I'll leave for Reed to talk about like what you've done with toolchains basically and how we can get a slimmer one for production.
and I've heard in the past rules Python like provides the toolchain, right? But before I think Bazel requires the OS to have a toolchain for some kind of first bootstrapping.
Yeah,
Yes.
There's a whole lot to go into here.
I can show you the quick version of how this is working in the demo because I pointed out that in this code space there is no system Python. But I was running PyBinaries using bootstrap logic. Like even the rules Python bootstrap logic did fail for me on this demo to begin with, trying to find a system interpreter. And I said, I am not willing to add a system interpreter. There is a flag. I mean, the punchline is always, did you know about this flag? Which is -- rules Python config settings bootstrap impl equals script. And if you pass that, it's not going to use Python to bootstrap the binaries anymore. It will use like bash instead. And they flipped, they're trying to flip the default for this. I think they probably will soon. And the issue here was the console script binaries, right? So when I ran copier, it's not using our rules Py runtime, it's using the original rules Python, and it has that bootstrap problem. Yeah.
I want to confirm my understanding of the Pi image layer. So is it going to create multiple tarballs that are then created as separate layers of the OCI image?
Yes, that's exactly right.
It's Pi image layer singular, but it's actually creating multiple layers, and that's the reason we want it.
Yeah, I agree the naming of that rule strikes me as a little wrong because it does produce more than one. And the layers ended up in Bazel bin app. Yeah, so like there's the actual tar file, then there's a manifest spec that lists all the files that went into it. So this is like the thing we handed to the tar program that says which files to put in each tar. This is kind of handy to look at in the Bazel out tree because you can see the tar listing without having to even construct it. Like this is a separate action we run before we run the tar action. And then there's another like JSON file basically that is the image. So that's the overall digest. And then I think these descriptors have like one of these things is going to be the digest of the tar file. And again, Malte's talk, I got to see a rehearsal of it. He does a great job of showing like the structure of a Docker container and how that relates to these layers. And he'll mention like the 3 different layers. So go check that out.
Sorry, I have one more
Yeah.
related to V. I know we didn't get to this part, but today is it possible to support UV run as well, or like delegate the whole virtual env to UV itself, or?
I think that's maybe my cue to hand over to Reed.
Okay.
Is that a good segue?
Yeah, sure. So by UV, let me just do the laptop dance here. So by UV run, you're referring to the using UV as your interpreter shebang. So you specify UV run with your dependencies.
Yeah, let me say like in which two I have like UV as like my hermetic UV and UV run, for example, I can have even inline script metadata like PEP721, and UV itself would create a virtual env that run everything like abstracted away from me. So I could just have, let's say, a .py utility in my workspace.
Yep.
I have some, I wouldn't say gene rule, but like whatever, that just call it my hermetic UV run that stuff, and it just magically works with Bazel without having the pip run or something.
So from my perspective, and obviously I'm biased, I just spent
Sure.
4 months of my life implementing UV under Bazel, which is what I'm going to talk about in like 90 seconds here. I don't see a great reason to do that unless you specifically want to participate in UV's non-hermetic caches outside of Bazel. Certainly, you could go write a non-hermetic rule, right, and it will just work. You can go invoke UV run with the appropriate Bazel flags to disable all the sandboxing and let it talk to its own external caches, and you can get that UV like quote unquote native experience outside of Bazel, right? But you're doing so non-hermetically, which means that you're really defeating the point of using Bazel in the first place. So from my perspective, there's not a super strong reason to go do that because the performance wins you're getting from doing that are coming from interacting with caches that aren't going to benefit you when you run Bazel test. And to me, at least, the whole reason to use Bazel in the first place is to get the test caching, right? And so if you have like one set of dependencies that's living outside of Bazel that makes you run fast, but you have to go rematerialize those dependencies using a different mechanism or worse, non-hermetically to run your tests, then you're not really getting the benefits that Bazel exists to provide. So I think choosing a different strategy that gives you hermetic dependencies via UV under Bazel, which is what I'm about to talk about, is the superior choice there, right?
Good, thanks.
So with that, this is just my 90-second demo here. This is the end-to-end tests straight out of the rules.py repo. We have a neat new thing in here, which is the UV parse. So this is an experimental extension to aspect rules.py that provides an implementation of using the UV lock file directly rather than using requirements text. I'm happy to go into the details, but the short version is that UV's lock file gives us way more to work with than the requirements text format does and makes it easy to go do a lot of really fancy and valuable stuff for you by default, whereas rules Python requires a ton of configuration in order to achieve the same results if they're even possible. In this example, what we're saying is I've got a UV hub. I only have one hub. It's called PyPy. And I actually have several different virtual environment solutions which are registered into the same hub. So here I have a Causse lock solution. I have an Airflow lock solution. And I have a Postgres lock solution, all of which are registered into the same hub. I don't have to worry about using the right like @pip _ like my other virtual environment. I just say pypy/requests, and that is always the requests as configured in the build, and that one hub indirects over all the virtual environments. So you can flip which virtual environment you're building against with a single flag. That's in fact a thing that we do here in the Say demo. The Say demo is a virtual environment that uses the Say virtual environment, and that just transitions the common label for cowsay to be whatever it is that we configure cowsay to be in that build. The neat part of this is cross-building. So because we're using UV's lock file, which gives us a ton of information, including the correct configuration for all your dependencies on alternate platforms, which is something that RulesPy has a really hard time getting access to for a variety of reasons, we can just say, hey, I want to go build for glibc at a certain version, or I want to go build for muscle on a certain version, targeting not my host architecture, right? On Rules Python, for a variety of reasons, it's kind of forced to configure targeting the host platform. So building from your Mac Darwin machine, your Darwin ARM machine to Linux AMD 64 has pretty much never worked, and kind of can't work because Rules Python configures all your pip deps on the host platform at repository execution time. It doesn't have the ability to go inspect what the alternative configuration would be. Shout out to Ignis. He does have some experimental code called pipstar that's making a Herculean effort to try to make that possible. I want to be very clear. He is working on this, and he's doing great work. However, he's working way uphill because the requirements text file just does not give you the information you need to be able to do this correctly or easily. The UV lock file does. And so by using the UV lock file, we're able to just make this work by default. This demo just shows, hey, same thing as what Alex was just showing. We've got a Pi binary. It depends on the Postgres driver, and we have two transition versions of it. We have the AMD 64 version and the ARM 64 version, and this all just works. If I just go grab this and I say build cases UV deps ... Bazel. This actually went and, well, I suppose that's too underwhelming. So if we run the app, just to show, right, we get an app. It has the files in it. If we go build the layers for the image, and we go list that out, we can go find the SO files in it, right? This has the Darwin version of those files. If we go rebuild this with the right platform flag, right? So we're going to say -- platform is target UV or cases UV, right? I'm just going to copy paste some stuff here. So cases UV cross build : and we called this the ARM 64 Linux, right?
Platforms plural.
Thank you.
We should take that S and put it on the Pi image layer.
Yeah, right. We have to go cross build some stuff because I'm going from source. I'm not sure why this isn't a cache hit because I definitely build all this as a part of my test suite, but it's actually going plenty quick here. So, and the output of this is, hey, we got a new tar file here, and if we actually just go back up to our tar list and grep for SO files, we now see that we have a ton of SOs in here that are correctly the Postgres SOs for ARM 64 Linux, right? So we've successfully cross-configured the Python application from Mac Darwin, or from Darwin ARM to Linux ARM, and just source built all of it from scratch. So this is coming soon to a BCR near you, as soon as I figure out some release issues.